the 4 questions from practice question set number 1 that we had on Google Classroom last night. Starting with question number 1, it says a 47.0 gram golf ball, is hit with an initial velocity of 70 meters per second at an angle of 30 degrees up from the horizontal. The vertical component of the ball's momentum is what? There's a couple things we got to be careful of here, right? Firstly, that we're looking for the vertical component of the ball's momentum, not the vertical component of the velocity. And secondly, that we've got a golf ball whose mass is 47 grams, but we got to make sure that we remember to convert that to kilograms. That's why we haul out the red pen or the highlighter or whatever it is and draw attention to this stuff that can lead to silly mistakes. Now, if you were in my class last year, we had a little phrase that we would recite every time we saw something like this. And we did see stuff like this in Physics 20, although not in the context of momentum. Does anybody from my Physics 20 class remember what that phrase is? Cameron remembers it. I could see it on her face. Kelly? I don't like funny angles. I don't like funny angles. 0 degrees is fine. 90 is fine. I'm fine with those. If something is parallel or perpendicular, I'm okay with those. No problem. But if I got an angle of 30 degrees or 40 or 62.9 degrees, whatever, I don't like those angles. I don't like any of those angles. So our goal is to get rid of them. And when we get rid of them, we end up breaking it down into an X component and a Y component. So then we have something that's just perpendicular like this, right? Instead of having something like this, we have something like this and this. And I can deal with those because I don't mind 0 and 90. I just don't like this. So here's how we get rid of that funny angle. We take it off to the side over here. We label it as 70 meters per second. That's my velocity. And then I draw a little triangle around the angle. Here's my X component. Here's my Y component. Here's my angle, 30.0 degrees above the horizontal or up from the horizontal. We're looking for the vertical component here. Usually at this point, when we're resolving an angle, we actually solve for horizontal and vertical. But in this case, since we're just looking for vertical, that's all I'm going to solve for. The vertical component, the Y component, which side of the triangle is that? Is it opposite, adjacent, or hypotenuse? It's opposite, right? It's opposite side. We've got the hypotenuse. Which trig function goes with opposite and hypotenuse? This is Physics 20, right? There's a little bit of Physics 30 in this question, in the idea that we're dealing with momentum, right? But for the most part, this is a Physics 30, Physics 20 question. Somebody said it. What is it? Which trig function is it? It's a sine function. We're going to say sine 30 degrees is equal to opposite over hypotenuse. And then that ends up being equal to 35.0 meters per second. Good. Look, I just solved for the vertical component of the velocity. Now what am I going to do if I want to find the vertical component of the momentum? Sorry? Guess? Yeah, just multiply by the mass. The Y component of the momentum is equal to the mass times the Y component of the velocity. So it ends up being 0.0470 kilograms. Yeah, I remember to convert that to kilograms, probably mainly because I had grams circled. It was my reminder to not forget to convert. 0.0470 kilograms times 35 meters per second. And I want to say it worked out to be A, is that right? 1.65 kilograms meters per second. Now, how many people did it that way? Anybody do it kind of in a different order? Okay, what'd you do, Kessler? Okay, so Kessler found the momentum, not the X or Y component, but the momentum by multiplying 0.047 times 70. That gave him a momentum at an angle of 30 degrees. Do you happen to have that number written down there? What is it? 3.29? Okay, so he got a momentum, and then what he did is found the Y component of the momentum by using sine 30 is equal to Y over 3.29. So bottom line is you got to do a Y component and you got to multiply mass times velocity, but it doesn't matter which one you do first. Either get momentum and find the Y component of that, or get the Y component of the velocity and then get momentum. Either way works. They'll give you the right answer. Notice one thing though. If you just multiply mass times velocity, look what you get. Go figure. Hey, go figure. This is what they do. This is what they do to us. Hey, this is what we got to live with, is doing something wrong or incomplete, and yet my answer's still there. Okay, so be careful. Are we good at that? So it's physics 30, right? Combined with some physics 20 stuff. All right, number 2 says, which of the following units are correct units for momentum? Easiest way to do this is to go to our impulse equation that we learned yesterday, right? What was that impulse equation? Impulse is equal to m delta v, but also impulse is equal to F times T. What are my units for impulse? Sorry, for momentum? Well, kilograms meters per second works, but also Newton times seconds works as well, right? F times T, Newton times seconds. Number 3, I really like this question. Number 3, I used to give this on unit tests, and probably about 60% of people would get it right, but like 40%, that's a pretty significant number, would get this wrong. And then every single one of them would kick themselves after they get their test back and saw how to actually do this question. You guys remember from physics 20, projectile motion? You remember there's 2 components to projectile motion, the x component and the y component, the horizontal and the vertical. You remember the y component of the projectile motion involves acceleration because it slows down vertically and then speeds up as it comes back down? You guys remember that? What about the horizontal component? What do we know about that? Yeah. The velocity doesn't change. So it's constant velocity horizontally, but acceleration vertically. And that gives you, does anybody remember the shape of it? A parabola, right? That's what gives you the parabola. Constant velocity horizontally and acceleration vertically. Right? Remember that? If the horizontal motion is constant velocity, then its velocity isn't changing. And if its velocity isn't changing, its momentum horizontally isn't changing. So if it's 800 up here, it's going to be 800 right here, and 800 right here, and 800 right here. The horizontal momentum stays 800 the whole time. Vertical changes, but the horizontal will stay the same the whole time. Right? And finally, question 4 says a 1,200 kilogram car traveling north at 20 collides with a 1,000 kilogram car traveling south at 24. What's the total kinetic energy and the total momentum? Total kinetic energy, total momentum. Well, we'll say that EK is equal to 1/2 m1 v1 squared plus 1/2 m2 v2 squared. There was a south there. I should have probably circled that. But I didn't pay any attention to it there when I put in the 24 meters per second. How come? Why didn't it matter here? Why did I not want to put in negative 24 for that? Yeah. Good. Speed goes into kinetic energy, not velocity. Let's figure out what this is. 0.5 times 1,200 times 20 squared. Add that to 0.5 times 1,000 times 24 squared. I get 5.28 times 10 to the 5. Okay, 5.28 times 10 to the 5 joules. So that means the answer is either going to be A or B. Now let's figure out the total momentum. We're going to say P is equal to m1 v1 plus m2 v2, which is 1,200 times 20 plus 1,000 times 24. But this time we're going to make this negative because momentum is a vector. Because momentum is a vector. Do this. Guess what the momentum works out to be? 0 kilograms meters per second or Newton seconds. So the answer would be B. Okay? Make sense?